In 1944, on a road outside Stockholm, a black Volvo PV801 sedan idled at a traffic light with a 6-foot steel barrel strapped to the back of its trunk. Smoke trickled from the top of the barrel. Inside it, oak chunks the size of a man's fist were slowly burning. The car was not a museum piece. It was the daily commuter of a Swedish accountant, and it was running entirely on wood. That accountant was not unusual. In 1945, 73,000 vehicles in Sweden, approximately 90% of every car, truck, bus, tractor, and farm vehicle in the entire country ran on wood gas. In Germany, the number was 500,000. Across occupied France, Denmark, Finland, the Netherlands, and Italy, the total exceeded 1 million vehicles by the end of the war. They were called holzgas in German, gengas in Swedish, gasifier in French. The technology was a 1920 French patent designed by an engineer named Georges Imbert. It cost less than $100 to install on any internal combustion engine. It used the same firewood you would burn in a fireplace. It produced enough engine power to drive a fully loaded truck up a mountain pass. After 1945, the patent expired. The technology was perfectly legal in the United States. It was never imported. By 1955, fewer than 200 wood gas vehicles existed across the entire North American continent. By the end of this video, you will discover exactly how a steel barrel and a pile of firewood can replace a tank of gasoline, why the American auto industry buried the technology that European countries used to win and lose a world war, and the 1989 federal manual that quietly explains how to build one in your driveway. Wood does not burn in your fireplace. This is not a metaphor. This is documented combustion physics taught in every chemical engineering program on the planet. When you put a log on a fire, what actually combusts is not the wood itself. It is the gases the wood releases when heated. At temperatures above 200 degrees Celsius, wood begins a process called pyrolysis. Hemicellulose breaks down into hydrogen, carbon monoxide, methane, and a class of complex organic vapors, collectively called wood tars. At 400 degrees, cellulose follows. At 500 degrees, lignin. The flames you see in your fireplace are these released gases burning in atmospheric oxygen, several inches above the wood surface itself. A wood gas generator captures those released gases before they combust. The wood is heated in an oxygen-restricted chamber. Pyrolysis proceeds. The released gases are then cooled, filtered, and routed into the intake of an internal combustion engine, where they burn cleanly inside the cylinder, exactly as gasoline vapor would. At the Royal Institute of Technology in Stockholm, engineers measured wood gas energy content continuously throughout the 1940s. Their findings are public record. 1 kilogram of dry hardwood produces approximately 2.5 cubic meters of usable wood gas. That gas contains roughly 18% carbon monoxide, 20% hydrogen, 5% methane, and the balance nitrogen and carbon dioxide. The energy density is approximately 5.5 megajoules per cubic meter, about half the density of natural gas, but more than enough to drive a standard internal combustion engine. In practical terms, 30 kilograms of dry hardwood, a single armload of firewood from a backyard woodpile, contains the equivalent energy of 10 liters of gasoline. At highway speeds, a converted Volvo PV801 averaged 25 kilometers on that armload. A converted Mercedes-Benz 170V truck managed 14 kilometers per armload, hauling a full ton of cargo. Both numbers are documented in the wartime fuel rationing records of the Swedish National Energy Administration, archives that remain open to public inspection. Now here is the number that changes everything. In 1944, Sweden's national petroleum imports had been cut by 92% due to Allied naval blockades. The country should have ground to a halt. It did not. Wood gas conversions kept the Swedish economy running through 5 years of total fuel deprivation. The country emerged from the war with a more efficient transportation network than it had entered with, 92%. That gap between what Sweden should have lost and what it actually lost in mobility during World War II represents what wood gas technology was capable of when an entire industrialized nation committed to it. But here is what makes this truly remarkable. We did not discover this technology. We forgot it. The French invented it. The Germans industrialized it. The Swedes nationalized it. The Finns refined it for sub-zero conditions. Different countries, different decades, identical principle. In 1920, a French engineer named Georges Imbert filed patent number 514 WWII with the French Patent Office for what he called the gazogène à charbon de bois, the charcoal gas generator. Imbert was working at the Industrial Society of Mulhouse, a research institution in eastern France, funded by textile manufacturers searching for alternatives to imported coal. His design used a specific downdraft architecture. Fuel entered the top of a cylindrical chamber. Air was drawn down through the burning fuel from above. The hot gases passed through a constricted throat at the chamber's midpoint, where temperatures exceeded 1,000 degrees Celsius. At that temperature, complex tars and hydrocarbons cracked into simpler combustible gases, primarily carbon monoxide and hydrogen. The result was a clean-burning fuel suitable for any internal combustion engine. By 1931, the Imbert design had entered mass production in Germany under license to the Köln-based firm Imbert Generatoren GmbH. By 1939, over 9,000 commercial wood gas vehicles were operating across Germany. The Weimar Republic's economic crisis of the early 1930s, combined with the Nazi government's four-year plan emphasis on energy independence, had made domestic wood gas a strategic national priority before the war even began. In Sweden, the National Wood Gas Bureau was established in 1936, 4 years before German occupation of Norway and Denmark cut off Swedish petroleum imports. By 1942, every Swedish gas station had been required by law to install wood drying racks alongside fuel pumps. The Swedish Forest Service produced standardized hardwood briquettes called gengas briquetter, dried to 12% moisture content, distributed through the National Fuel Rationing Program. Sweden built 73,000 wood gas conversion kits at state-subsidized prices between 1939 and 1945. In France, after the German occupation began in 1940, the Vichy government distributed Imbert generators free of charge to farmers, doctors, and essential service workers. By 1943, France had approximately 250,000 wood gas vehicles in service, including the entire Paris taxi fleet. The famous Renault Juve-Quatre Saloon, France's most popular pre-war family car, was modified by tens of thousands of owners to run on charcoal gas using a kit that fit in the trunk. Finland adapted the technology for sub-zero operation. The Finnish State Engineering Works in Tampere developed insulated wood gas generators that started reliably at -40 degrees Celsius, conditions where gasoline engines fail. By 1944, Finnish military convoys were running entirely on wood gas through Lapland winters that would have stranded petroleum-fueled vehicles. Every European country that lost access to petroleum during the war independently scaled wood gas technology to industrial levels. France, Germany, Sweden, Finland, Italy, the Netherlands, Belgium. 25 years of proven engineering across an entire continent. Then in less than 15 years after the war ended, the technology vanished from the developed world entirely. Then in less than 15 years, it vanished. One country, one industry, one government policy. In 1945, the United States produced 67% of the world's petroleum. Texas, Louisiana, Oklahoma, and California pumped more crude oil than every other country combined. American gasoline cost the equivalent of roughly 23 cents per gallon in 2024 dollars throughout the late 1940s and 1950s. There was no economic pressure to develop alternative fuels. The American auto industry took full advantage. In 1947, the Society of Automotive Engineers, SAE, published technical paper number 470158, which evaluated wood gas conversion technology against gasoline operation. The paper's conclusions, written by engineers from General Motors and Ford, dismissed wood gas as, quote, suitable only for emergency conditions in fuel-deprived regions, end quote. SAE recommended against any commercial development of the technology in the United States. By 1956, the Eisenhower administration had signed the Federal Aid Highway Act, committing $25 billion to the construction of the interstate highway system. The entire infrastructure was designed around liquid fuel, service stations every 30 miles, standardized gasoline pumps, tanker truck delivery routes. Wood gas conversion required none of this infrastructure. It also generated none of the recurring revenue that the integrated oil industry depended on. The Marshall Plan, signed in 1948, provided $13 billion in U.S. aid to rebuild Europe after the war. A condition of that aid was the modernization of European energy infrastructure. American oil majors, including Standard Oil of New Jersey and Texaco, signed long-term contracts to supply petroleum to reconstructed European economies. Within a decade, the wood gas vehicles that had powered Europe through the war had been retired, scrapped, or sold to museums. By 1965, the technology that had moved 1 million vehicles existed only in academic papers and surviving farm equipment in remote rural areas. The American education system never taught it. Mechanical engineering programs never covered it. Automotive trade schools never trained for it. The 1989 edition of the Marx Standard Handbook for Mechanical Engineers, the most widely used reference text for American engineers, allocated exactly 0 pages to wood gas vehicle technology. The same handbook devoted 47 pages to internal combustion engine fuel injection systems alone. The technology was not disproven. It was systematically erased from the American technical consciousness. The average American driver born after 1960 has never been told that wood gas is a viable alternative fuel. The average American mechanic has never disassembled an Imbert generator. The chemistry has not changed since 1920. The patents are public domain. The engineering is straightforward, but the physics never changed. And in Sweden, Finland, Brazil, North Korea, and rural Alabama, engineers have continued building Imbert generators without interruption for the entire century since the original patent. At the Technical University of Denmark in Lyngby, researchers have continuously studied wood gasification since 1949. Their published research includes the 2018 paper in the journal Biomass and Bioenergy, documenting modern Imbert-derived gasifiers, achieving 78% energy conversion efficiency, comparable to modern diesel engines. The DTU team operates a working wood gas vehicle test fleet in conjunction with the Danish Technological Institute. Their published cost data shows wood gas fuel costing approximately 12% of equivalent gasoline at current European prices, with payback period for conversion equipment averaging 18 months at typical farm or commercial driving distances. In Sweden, the Swedish National Road and Transport Research Institute has maintained continuous wood gas research since 1945. Their archives include design specifications for over 2,400 documented wood gas vehicle models from the wartime period, freely available to any researcher who requests them. The Institute publishes annual updates on biomass to vehicle fuel efficiency, treating wood gas as one acknowledged option among many for European transportation electrification. In rural Alabama, a self-taught engineer named Wayne Keith has driven wood gas-powered Dodge trucks continuously since 2003. Keith's published book, Have Wood Will Travel, documents over 600,000 miles of road testing across all 48 contiguous states. His current truck achieves the equivalent of 35 miles per pound of dry hardwood. He fuels it for free using fallen branches, sawmill waste, and discarded shipping pallets. In Berkeley, California, a company called All Power Labs has manufactured commercial Imbert-derived gasifiers since 2008. Their power pallet generator system produces continuous 20-kilowatt electrical output from wood chips, sized for off-grid homes and small commercial installations. The technology is verified, the units are CARB compliant in California, and they sell for between $25,000 and $60,000, depending on configuration. They are also in continuous back order. In 1989, the Federal Emergency Management Agency, FEMA, published Technical Document SR 1989. The full title reads, quote, Construction of a simplified wood gas generator for fueling internal combustion engines in a petroleum emergency, end quote. The 79-page manual, authored by H. LaFontaine and F.P. Zimmerman, contains step-by-step engineering drawings for an Imbert-derived gasifier that any competent welder can construct using salvaged steel and standard hardware. The manual remains a public federal document, downloadable for free from the FEMA archive at fema.gov. The same federal government that produced this document has otherwise pretended for 60 years that wood gas conversion is not a real option for American vehicles. The chemistry has not changed since 1920. The Imbert patent is in the public domain. The FEMA manual is publicly available. Every component required to build a wood gas generator is sold by U.S. Steel, Home Depot, and Tractor Supply Company. So why has American transportation policy continued to ignore this for 80 years? Open the United States Code of Federal Regulations to Title 40, Part 86. the Environmental Protection Agency's emission standards for motor vehicles. You will find detailed requirements for gasoline emissions, diesel emissions, natural gas emissions, propane emissions, and ethanol emissions. You will find no provisions for wood gas emissions. The fuel category does not exist in EPA regulatory documents. A wood gas converted vehicle is not technically illegal to operate, but it cannot be certified for emissions compliance through any standard process. State motor vehicle inspection regimes do not have a checkbox for it. The Department of Transportation does not prohibit wood gas vehicles. It also does not authorize them. They exist in a regulatory gray zone where individual operators can build and drive them on private property without restriction. But commercial production for road use requires navigating a permitting process that no agency is prepared to administer. Follow the money, and the picture sharpens. The global petroleum industry generated $4.7 trillion in revenue in 2024. The American oil and gas sector employs 10.3 million people, directly and indirectly. The American Petroleum Institute, the industry's primary trade group, spent $124 million on lobbying activities in 2023 alone. Combined campaign contributions to federal candidates from oil and gas interests exceeded $215 million in the 2024 election cycle. Every dollar of that spend depends on Americans continuing to fuel their vehicles with petroleum products. The American auto industry has its own incentives. Each conventional vehicle generates approximately $1,400 in dealer service revenue per year, primarily from oil changes, fuel system maintenance, and emission control system repairs. Wood gas vehicles eliminate most of these revenue streams. Engine wear is actually lower because wood gas burns cleaner than gasoline. There is no fuel system to maintain. The gasifier itself requires periodic cleaning, but uses no proprietary parts. In 2010, an entrepreneur named Berto Pandolfo proposed mass production of a Volkswagen Beetle-based wood gas vehicle for the South American market. He received zero financing from American or European lenders. The project quietly folded by 2013. In 2018, an Iowa farmer named Dave Bischoff attempted to sell wood gas conversion kits at agricultural trade shows. The Iowa Department of Transportation issued a cease and desist letter within 60 days, citing emissions inspection compliance concerns. He stopped manufacturing. The codes are written against you. The industry profits from your ignorance. But here is what they cannot take away. The chemistry works regardless of what any regulator says. Somewhere in the woodpile behind every rural American home right now, the same fuel that powered 1 million European vehicles through the Second World War is sitting unused, perfectly legal to burn, free to convert. Here is exactly how to build one yourself. Before you weld a single piece of steel, you need 3 pieces of information: your local emissions inspection requirements, your access to dry hardwood, your vehicle's compatibility with gaseous fuel. Pull up your state's motor vehicle emissions inspection program. In 17 states, including Texas, Florida, and most of the rural West, no emissions inspection is required for personal vehicles. In these states, wood gas conversion is fully legal for personal use. In states with emissions inspection, your converted vehicle will fail standard testing because there is no wood gas test category. You can still drive on private property indefinitely, including farms, ranches, and forestry operations. Know your wood. Dry hardwood, ideally oak, hickory, ash, or maple, with moisture content below 20%, is the standard fuel. Softwoods like pine work, but produce more tar and require more frequent cleaning. Wood must be cut into chunks roughly fist-sized, between 5 and 10 centimeters across. A typical wood gas conversion consumes approximately 1 kilogram of wood per 8 to 12 kilometers of driving. And know your vehicle. Older carbureted engines, manufactured before 1990, are easiest to convert because they accept gaseous fuel through the existing carburetor with minor adjustments. Modern fuel-injected engines require additional electronic controls. Diesel engines can run wood gas in dual fuel mode, where wood gas provides 70% of the energy and diesel provides ignition. Here are the materials for an Imbert-derived wood gas generator capable of powering a small truck or generator. One 30-gallon steel drum, ideally a discarded propane tank or chemical drum. The walls must be at least 1.5 millimeters thick, free from scrap yards or $50 new. Stainless steel grate material for the fire grate, $30 from any welding supply. sheet steel for the throat construction, the cooling tubes, and the filter housing. Approximately $80 total. A water filter housing, the kind used for whole house drinking water filtration, repurposed as a final tar filter. $40 at any home improvement store. Approximately 10 meters of 1.5-inch flexible exhaust hose for the gas piping. $35 at an automotive parts store. Standard hardware, clamps, bolts, gaskets, fittings. Approximately $60 total. Plus, critically, the 1989 FEMA manual itself. Free download from FEMA.gov. Search for SR-1989 and the document downloads as a PDF. Total materials cost, approximately $295 to $400, depending on what you can salvage. The manual is free. For comparison, a conventional gasoline tank holds the equivalent of $40 to $60 worth of gasoline at current prices. The wood gas generator, once built, replaces that tank for the lifetime of the vehicle. Construction takes a competent welder, approximately 40 to 60 hours of labor. The fabrication is straightforward, but requires precision in 3 critical dimensions. The throat constriction, where pyrolysis tars crack into clean fuel gas, must be machined to within 2 millimeters of the FEMA manual specifications. The fire grate elevation above the gas exit must be within 1 centimeter. The cooling tube length must be at least 3 meters of total flow path to drop the gas temperature below 50 degrees Celsius before it enters the engine. Get those 3 dimensions right and the system works. Get them wrong and the gas contains too much tar, which fouls engine valves within 100 miles of operation. The FEMA manual specifies all 3 dimensions precisely. Vehicle conversion requires modifying the carburetor to admit a second air-fuel mixture. The simplest method is a T-fitting installed between the air filter and the carburetor inlet, with a manual valve allowing the operator to choose gasoline, wood gas, or a blend of both. For starting, gasoline is used. Once the wood gas generator reaches operating temperature, approximately 5 minutes from cold start, the operator switches to wood gas and shuts off the gasoline supply. Maintenance is moderate. The fire grate requires cleaning every 200 to 400 kilometers, removing accumulated ash and clinker. The cooling tubes require cleaning approximately every 1,000 kilometers, removing condensed tars. The water filter requires replacement every 2,000 kilometers. None of these intervals are onerous compared to conventional vehicle maintenance. Operating cost runs approximately 4 cents per mile for fuel, including labor for wood preparation. Conventional gasoline operation runs approximately 16 cents per mile. The 4-to-1 cost advantage compounds over the lifetime of the vehicle. Total time to a working conversion, including fabrication, vehicle modification, and shakedown testing. Approximately 80 to 120 hours of skilled labor. Total monetary investment, approximately $400 in materials, plus the cost of any necessary welding equipment if you do not already own it. The FEMA manual exists. The Imbert patent is public domain. The chemistry has not changed since 1920. The 1 million European drivers who relied on this fuel during the Second World War did not have access to YouTube tutorials or online supplier networks. They simply built the systems and drove the vehicles. Sweden survived a 92% reduction in petroleum imports because every gas station in the country had been retrofitted with a wood drying rack. Germany kept 500,000 vehicles operational throughout 6 years of total economic warfare because Georges Imbert's 1920 French patent had been mass-produced under license a decade before the war began. France, Finland, Denmark, and Italy all maintained civilian and military mobility on a fuel that grew on trees. After 1945, American gasoline was so cheap that no one in the United States bothered to import the technology. By 1965, the entire generation of European mechanics who had built and maintained these systems were retired. By 1990, when FEMA published its emergency wood gas manual in case of a future petroleum crisis, the document was buried so deeply in federal archives that even most preparedness organizations had forgotten it existed. The chemistry is older than the petroleum age. It will outlast whatever comes next. The wood is sitting in the forest behind your house. The Imbert patent is on your phone right now if you search for FR 514289. The FEMA manual is one Google search away. It has always been waiting.